Now we're going to go through the I-1 reflection solution. So these are the problems associated with hypothesis testing. We've just started the basics. And we'll have some review of some other things as well. So which of the following is a true statement? Statement A well-planned hypothesis test should result in a statement that either the null hypothesis is true or it is false. We never know if anything is true or false for sure in stats. We can only find convincing evidence to change our mind. We have to stick with the assumed null unless we have evidence to say, maybe the alternate's the way to go. Okay, the alternative hypothesis is stated in terms of a sample statistic. No, it's stated in terms of the null hypothesis, so the null hypothesis is saying something about a parameter. And our alternate is saying, hey, we think it's something else about that parameter. If a sample is large enough, the necessity for it to be a simple random sample is diminished. No, we need randomization so we can eliminate bias. So randomization is, and again, it doesn't have to be simple random. It just has to be random because you have other good methods of randomization like systematic, cluster, stratified. Those are all valid methods of sampling. All right, when the null hypothesis is rejected, it is because it is not true. No, it's just that we have evidence for the alternate, so that it's probably not true. We don't know that it's really not true. Hypothesis tests are designed to measure the strength of evidence against the null hypothesis. That's exactly right. That's what we're doing. We're trying to say, hey, do we stick with our assumptions or did our research show we should change our mind? So E is the correct answer. Number 2, which of the following is a true statement? The p-value of a test is the probability of obtaining a result as extreme or more extreme as the one obtained, assuming the null hypothesis is false. So the p-value is probability of obtaining a result. So it's so close. A is so close to being right. If it said the null hypothesis is true, A would be a true statement. All right. So that is what the p-value is. It's the probability of obtaining a result as extreme or more as the one obtained, assuming the null hypothesis is true. We build our world around the null hypothesis, assuming it's true, and then we see if our data fits our world. If it fits our world, we don't change our mind, okay? If it doesn't fit our world, then we're like, oh, this is convincing. We need to change our mind. Okay. If the p-value of a test is 0.015, the probability that the null hypothesis is true is 0.015. No, it's not the probability that something is true. This is kind of like parameters. The null hypothesis is either true or it's not true, all right? It's not trying to change its mind. It is either true or not true. So there's no predicting that it's true. We're just trying to measure and estimate. So B is also false. The larger the p-value, the more evidence there is against the null hypothesis. It's actually the opposite. Oops, I skipped. So I'll do C first. No, that's right. The larger the p-values, mean the probability is not that unlikely, so it's not very convincing. The probability of getting what we got is kind of high based on our model. So maybe our model's okay. Part D. If possible, always examine your data before deciding whether to use a one-sided or two-sided hypothesis test. This is super tempting, but technically, first of all, if you did that, you're only going to use one-sided hypothesis tests because your data is not going to be both higher and lower than you're not going to have a statistic that's higher and lower than your parameter. It's either going to be higher or it's going to be lower. And if you use your data to decide that, you're only going to do one-sided tests. Sometimes we use two-sided tests when we just want to know, is it not equal to, all right? When both higher and lower are interesting to us. For example, the 1 in 6 game, you could argue, so usually I have you do a one-sided because I say she's worried that it's lower or she's worried that it's higher. In reality, she's worried about both. So you could do a two-sided hypothesis test on that problem. E, The alternative so there you go. Always set up your hypotheses before you gather your data. Okay. The alternative hypothesis is one-sided if there's interested in deviations from the null hypothesis in only one direction. So the way I've been doing the 1 in 6 game, I've been wording it so I'm only worried about things being higher. Or in later problem, and when I ask again, I might only be worried when things are lower. So frequently when I do that, I'm only interested in deviations to one side. Now someone said, I'm confused on how standard deviation affects hypothesis. Standard deviation is not deviation. Deviation means a difference from the true and the actual. So they're differences from the parameter, all right? They're not standard deviations. So our correct answer is E. Number 3, a hypothesis test comparing two population proportions results in a p-value 0.032. Which is the following is a proper conclusion? So the probability of seeing a sample result that or more extreme given that the null hypothesis is true is 0.032. So this is correct. So p-values are the probabilities of a result or more extreme in a world where the null hypothesis is true. That is what a p-value is. Write it down somewhere. Okay. Part B's and C, the probability that the null hypothesis is true or that the alternative hypothesis is true. It's not the probability that the hypotheses are true. Those hypotheses are actually really true or really false. They're not flipping around. We're not trying to predict. They are. They have a value. So it's not changing. All right. Parts D and E, p-values are probabilities of sample results. All right. Not differences in proportions. So those two are false. So A is correct. And you want to memorize that wording because that's pretty much how we interpret a p-value. A 1993 Los Angeles Times poll of 1,703 adults revealed that only 17% thought the media was doing a very good job. With what degree of confidence can the newspaper say that 17% plus or minus 2% of adults believe the media is doing a very good job? So we're trying to find confidence level, and we know the margin of error. So first of all, there's the confidence interval, right? So that's a form 17% plus or minus 2%. So that 2% is the second part, right? The margin of error. And so the margin of error is just the second part here, right? Over here, the Z star critical value times our standard deviation. And this is a proportion because they said 17%. So we go ahead and substitute in. Now, we're doing it from a statistic, so that's why we have p hat in here. And we have 0.17, then we have 0.83, 1703, and we do our math, and then we solve, and we get 2.197. So if I, just to give you the visual, I'm going to show you the staplet, then I'll do the calculator. So here's the staplet, and I have my Z value, so I put 0, and I put 1. And then I put this as my left and my right boundary, and the area captured is 0.972 or 97.2%. All right, now let's show you how to do it with the calculator. Now, where's my play? There you are. So we're trying to find the confidence level, which would be the percent of area. So I want second distribution. We're using the normal, and our choices are normal CDF and inverse norm. Since we're dealing with critical values, it's tempting to go to inverse norm, but I actually have my critical value. So I'm going to go to normal CDF, and I'm going to put in negative 2.197 for my lower, and positive 2.197 for my upper. And then just make sure that I'm using Z values here, 0 and 1. And then hit enter, and it will give you the area, which is 97.197, or basically 97.2%. There we go. So 97.2% is the correct answer. This is probably the most algebra you're going to use when you're doing these standard errors equals some value, like a margin of error. So get comfortable doing that. It's not too bad if you practice it a little bit. And again, I'm talking to those people who are algebra leery. Number 5, a newspaper advice columnist asked her readers if they would have married their current spouse if they had it to do over again. Of the 25,000 or so responses, 80% said no. This is actually based on a true story, by the way. What does this show? Well, she asked for volunteers. Big no-no. This survey is meaningless. It is trash, because who's going to bother to call up to say, no, I'd never marry again? All the disgruntled people, right? Whereas, if they would have married their current spouse, no, I wouldn't have married my current spouse. Now, I think based on divorce rates, that's closer to a 50% divorce rate. It's not 80% divorce rate. So this is overestimating how many people would not marry their current spouse. I personally will be happy to hit 37 years this summer. Which of the following statements is incorrect? So we have to look at every one. The mean of the sampling distribution of X bar is equal to the population mean, even if the sample size is small. That is true, right? We only get bias when we're not using proper sampling methods, all right? So bias doesn't really depend on sample size. Variability does. B, the sampling distribution of X bar has a standard deviation sigma over square root of n, even if it's not normally distributed, and even if n is small. That is correct, all right? So yes, that formula is fine, all right? And really, the only time we're really worried about this is really the 10% condition, okay? The sampling distribution of X bar is normal no matter what n is if the population has a normal distribution. That is true as well. If you start with a normal distribution, you're going to get a normal distribution. Things tend to the normal. If you start with a normal, you're already there. When n is large, the sampling distribution of X bar is approximately normal, even if the population is not normal. Even if the population is not normally distributed. That's true. That's the central limit theorem, all right? Even if the observations are not independent, the central limit theorem will apply as long as n is large enough. Actually, observations must be independent. Otherwise, we have to use something called conditional probability, and we don't want to do that. So E is the correct answer. Number 7. So this one throws a lot of people off. Set has 5 outliers. If every value is increased by 20%, how many outliers will there be? I was confused why the outliers in problem 7 did not change when the values are increased in 20%. Okay, so I had several that said, I don't understand this one. So using the most commonly accepted definition of outliers, a set has 5 outliers. If every value in the set is increased by 20%, how many outliers will there be? So basically, here's what I did. I said, okay, I made up some data. Here's the first set of data, and I created a box plot. Then I said, okay, let's increase all the data by 20%. So 1.2 times 10 is 12. 1.2 times 20 is 24. 1.2 times 80 is 96, right? And then I put all that data in. And here's my original box plot. And here's my modified box plot. You can see I have 2 outliers. So again, I'm not worried about getting all 5, right? So I created my own set of data, which has only 2 outliers. When I increased everything by 20%, my outliers stayed the same. Why? Because basically the z-scores for the original data for 100, which is one of the outliers, right, is 2.403. When my z-score for the new 100, which is 120 over here, is also 2.403. So the distance from the mean, remember the mean rose here, or really the median in this case, but the mean also rose 20%, all right? So everything is rising 20%. So anything that was an outlier is still an outlier. But things that are not outliers are still in the same range. And so scaling and shifting doesn't affect z-score. So it also doesn't affect whether a data point is an outlier or not. So the correct answer here is 5. It's unchanged. Hope that cleared that up. Number 8. The American Medical Association, AMA, wishes to determine the percentage of obstetricians who are considering leaving the profession because of the rapidly increasing number of lawsuits against obstetricians. How large a sample should be taken to find the answer to within plus or minus 3% at the 95% confidence level? Now, this is multiple choice, so you could actually go and substitute and calculate. But we're going to do this from scratch. So first of all, my margin of error is 0.03. My confidence level is 0.95, so I know my critical value is 1.96. You should have that one memorized. All right. So I write down my formula. That should look familiar. And we substitute. Now, one thing I didn't tell you is what is P, right? And I don't have a sample. So this is some information. It's in your notes, and we'll discuss it when we have our quiz, or we should have discussed it depending when you do this review, yes? You basically just go ahead and put in 0.5 in for P if you don't know what P is. This is the worst case scenario when standard deviation is going to be the biggest. So here we go. We got 0.03 and 1.96 and 0.05. So we square both sides, right? Everything gets squared. And so I end up, the square root just pops out. It's 0.25 over n, and these two are just the above squared. Then I can go ahead and put the n on the other side and divide by the 0.0009, and I get 1067.11. Now you might be tempted to say, oh, it's C. Well, if I have 1067, this margin of error is going to be a teensy bit bigger than 3%. And I want it to be 3% or slightly less. So I need to always round up. I need to use 1068. Which among the following would result in the narrowest confidence interval? Big sample size, tighter confidence, right? That's how you get the tiniest interval. So large sample size, 95% confidence. There you go. So that should be quick. 10. In a high school of 1,650 students, 132 have personal investments in the stock market. To estimate the total stock investments made by students at the school, 2 plans are proposed. Plan 1 would sample 30 students at random, find a confidence interval of their average investment, and then multiply both ends of their interval by 1,650 to get an interval estimate of the total investment. Plan 2 would sample 30 students at random from among the 132 who have investments in the market, find a confidence interval for their average investment, and then multiply both ends of this interval by 132 to get an interval estimate of the total investment. All right, so they're both using basically the same thing, right? The only difference is which students are they sampling from. Plan 1 is sampling from all students. Plan 2 is sampling from the ones who have investments. Well, we don't need to look at all students. We're just looking at the 132 students who have investments because the other ones don't. Their answer is 0. So we would just go ahead and go plan 2 because that's sampling our target population. 11. 2 possible wordings for a questionnaire on a proposed school budget increase are as follows. The school district has one of the highest per student expenditure rates in the state. This has resulted in low failure rates, high standardized test scores, and most students going on to good colleges and universities. Do you support the proposed school budget increase? Ooh, I'm feeling response bias coming on. So should I? I think I should. Look at all the good things there. Low failure rates, high standardized test scores, going to college and universities. How can I say no? I would seem evil. All right, number 2. This school district has one of the highest per student expenditure rates in the state. This has resulted in high property taxes, with many people on fixed incomes having to give up their homes because they cannot pay the school tax. Do you support the school budget increase? What kind of person is going to vote for a school budget increase and put these poor old people out of their homes? I have to vote against it. So, Q1 shows the benefits of high taxes, so more will vote in favor, whereas Q2 shows the disadvantages of the high taxes, so less will vote in favor. So if you had 2 survey results with these, right, one said 58% in favor, and the other one said 13% only in favor, question 2 is going to be 13%, right? And question 1 is going to be the 58%. And that's because of response bias due to wording of the questions. 12. Suppose that for a certain Caribbean island in any 3-year period, the probability of a major hurricane is 0.25, the probability of water damage is 0.44, and the probability of both a hurricane and water damage is 0.22. what is the probability of water damage given that there is a hurricane? So we see the word given. Oh, that means we need the given probability formula right there. So I'm going to replace A and B with water and hurricane. What is the probability of water given hurricane? Is the probability of water and hurricane over the probability of hurricane. Water and hurricane, they said, is 0.22. Hurricane is 0.25. Voila. There's your answer. D. 13. Suppose you wish to compare AP statistic exam results for the male and female students taking AP stats at your high school. Which is the most appropriate technique for gathering the data? Oh, I do what I do every year. There aren't that many. I have a nice report. I have all the data. I do a census. There you go. 14. For the regression line, which of the following statements about residuals is true? So, influential scores have large residuals. Not actually, not necessarily. It can pull the line all the way through it. So if you have a lot of data points here on the lower left, and then you have one up here on the right, that line's going to go smack dab through that influential point, all right? If the linear model is good, the number of positive residuals will be the same. Oh, that's pretty definite, as the number of negative residuals, all right? Well, it's most likely going to be about, but it says equals. Not good. False. So the mean of the residuals is 0 is correct. So remember when we did standard deviation and we had our deviations? Residuals are like that too. So the mean of residuals is always 0. If correlation is 0, then we don't necessarily have a distinct pattern. That means there'd be a pattern. There's some sort of relationship. And if correlation is 1, we could still have a distinct pattern. Maybe another fit would be even better.